Hello everybody, let's solve a multi-step equation that involves parentheses. Now solving any equation, the goal is always the same. We want to get the variable all by itself on one side. It doesn't matter which side, but it's got to be by itself. All right? Now when we present equations that have parentheses, that doesn't change the way the equation is solved, it just adds one extra obstacle. So the first thing I want to do when presented with this equation right here, which is 7y plus 7 times 2y minus 12 equals 3y minus 14. Well, the first thing that I'm going to do is I am going to get rid of these parentheses. So I'm going to take this part right here. Now I'm putting a box around the plus sign because it's important to know that the plus sign is also a positive sign and this minus sign is also a negative sign. So I'm multiplying a positive 7 times a 2y minus 12. So I'm multiplying a positive 7 times 2y, and then a positive 7 times a negative 12. Okay, and this is the distributive property, which I'm sure you're familiar with. All right. So when I do this, when I multiply this 7 times 2y, I wind up with 14y, and then of course 7 times a negative 12 gives us a negative 84. Okay. So when I distribute this, when I take care of what's here on the box, I'm left with 7y and then plus 14y minus 84. Now again, this is a plus sign here because again, 7 times 2y is positive 14y. So there's the plus 14y. And let's finish the equation here. So equals 3y minus 14. Okay? So here, looking at the left side of the equation, hopefully you recognize that I have like terms. I have this 7y plus 14y, which we could simplify that before moving forward. So 7y plus 14y leaves us with 21y, and then let's bring down everything else. Minus 84 equals 3y minus 14. So both sides are simplified. Now we have to get to the part where we're going to go ahead and take all of the variable terms and put them on one side and all the constant terms and put them on the other. So I like to make my variable terms positive when I can. It's not always possible, but that's what I prefer to do. But it really doesn't matter. I can choose any side to have my variables. In this case, I'm going to choose to subtract 3y from this side. Of course, if I subtract 3y from this side, I have to subtract 3y from the other side as well. Now, of course, 3y minus 3y leaves us 0, so 0y, and 21y minus 3y leaves me with 18y. So let's bring everything else down. Okay, so I'm left with 18y minus 84 equals negative 14. All right. Now, there's two things standing in the way of getting this variable by itself: the times 18 and the minus 84. Let's get rid of this minus 84 by adding 84. So if I add 84 to this side, I need to add it to the other side as well. Now, a negative 84 plus 84 leaves me with 0, and a negative 14 plus 84 leaves me with 70. Let's bring my 18y down. So I'm left with 18y equals 70. All right? Now, to finish this up, the last thing I have to do is I have to get rid of this times 18. What I'll do then is I'll divide both sides by 18. Now, of course, 18 divided by 18 leaves me 1, so I'm left with 1y, or just y. And this 70 divided by 18, I can leave it like that if I want, but you should reduce that. So 70 divided by 18 we can reduce to, instead of 70 over 18, I could say it's 35 over 9. I reduced both of these numbers by 2. Of course, I could take this improper fraction and I can convert it to a mixed number, which would give me 3 and 8/9. So all three of these answers are acceptable answers. I think these two are more acceptable because they're reduced. But now, let's say you're presented with a problem that has parentheses on both sides. You're going to follow the same process. You're going to use the distributive property on one side, use it on the other side, and then you're going to solve the equation like you've been solving them since you started out by solving basic ones like x plus 7 equals 12. If you have any questions, comments, please post them below. Thank you very much for watching, and good luck.